Retrocausality, also called retrocausation, retrochronal causation, backward causation, and similar terms, is any of several hypothetical phenomena or processes that reverse causality, allowing an effect to occur before its cause. Retrocausality is primarily a thought experiment in philosophy of science based on elements of physics, addressing the question, can the future affect the present, and can the present affect the past? Philosophical considerations of time travel often address the same issues as retrocausality, as do treatments of the subject in fiction, although the two terms are not universally synonymous. While some discussion of retrocausality is confined to fringe science or pseudoscience, a few physical theories with mainstream legitimacy have sometimes been interpreted as leading to retrocausality. This has been problematic in physics, because the distinction between cause and effect is not made at the most fundamental level within the field of physics. As philosophy. Although philosophical efforts to understand causality extend back at least to Aristotle's discussions of the four causes, the idea that the arrow of time could be reversed is substantially peacocked or more recent dated info. In fact, retrocausality was long considered an inherent self-contradiction, because, as 18th-century philosopher David Hume discussed when examining two related events, the cause, by definition, is the one that precedes the effect. Furthermore, the ability to affect the past suggests that causes could be negated by their own effects, creating a physical paradox, such as the well-known peacock term grandfather paradox. In the 1950s, Michael Dummett wrote in opposition to such definitions, stating that there was no philosophical objection to effects preceding their causes. This argument was rebutted by fellow philosopher Antony Flew, and, later, by Max Black. Black's bilking argument held that retrocausality is impossible, because the observer of an effect could act to prevent its future cause from ever occurring. A more complex discussion of how free will relates to the issues Black raised is summarized by Newcomb paradox. Essentialist philosophers have proposed other theories, such as proposing the existence of genuine causal powers in nature, or by raising concerns about the role of induction in theories of causality. More recent dated info vague philosophical inquiries into the topic have often adapted aspects of modern physics, including the hypothetical tachyon particle, and certain time-independent aspects of quantum mechanics. Jan Fay of the University of Copenhagen has argued that logical objections to macroscopic time travel may not necessarily prevent retrocausality at other scales of interaction. Even if such effects are possible, however, they may not be capable of producing effects different from those that would have resulted from normal causal relationships. As physics. Established physics does not generally employ retrocausality. Nevertheless, a number of theories allowing particles or information to travel backward in time have been proposed by prominent scientists, or have received meaningful evaluation by the scientific community. Antimatter. Time runs left to right in this Feynman diagram of electron-positron annihilation. When interpreted to include retrocausality, the electron, marked E, was not destroyed, instead becoming the positron, E+, and moving backward in time. As the modern understanding of particle physics began to develop, retrocausality was at times employed as a tool to model the unfamiliar or unusual conditions, including electromagnetism and antimatter. The Wheeler-Feynman absorber theory, proposed by John Archibald Wheeler and Richard Feynman, uses retrocausality and a temporal form of destructive interference to explain the absence of a type of converging concentric wave suggested by certain solutions to Maxwell's equations. These advanced waves don't have anything to do with cause and effect, they are just a different mathematical way to describe normal waves. The reason they were proposed is so that a charged particle would not have to act on itself, which, in normal classical electromagnetism, leads to an infinite self-force. Feynman, and earlier Stackelberg, proposed an interpretation of the positron as an electron moving backward in time, reinterpreting the negative energy solutions of the Dirac equation. Electrons moving backward in time would have a positive electric charge. Wheeler invoked this concept to explain the identical properties shared by all electrons, suggesting that they are all the same electron with a complex, self-intersecting world line. Yoichiro Nambu later applied it to all production and annihilation of particle-antiparticle pairs, stating that the eventual creation and annihilation of pairs that may occur now and then is no creation or annihilation, but only a change of direction of moving particles, from past to future, or from future to past. The backwards in time point of view is nowadays accepted as completely equivalent to other pictures, but it doesn't have anything to do with the macroscopic terms cause and effect which do not appear in a microscopic physical description. Current topics. Open topics in physics, especially involving the reconciliation of gravity with quantum physics, suggest that retrocausality may be possible under certain circumstances. Closed time-like curves, in which the world line of an object returns to its origin, arise from some exact solutions to the Einstein field equation. Although closed time-like curves do not appear to exist under normal conditions, extreme environments of space-time, such as a traversable wormhole, or the region near certain cosmic strings, may allow their formation, implying a theoretical possibility of retrocausality. The exotic matter or topological defects required for the creation of those environments have not been observed. Furthermore, Stephen Hawking has suggested a mechanism he describes as the chronology protection conjecture, which would destroy any such closed time-like curve before it could be used. These objections to the existence of closed time-like curves are not universally accepted, however. Retrocausality is sometimes associated with the non-local correlations that generically arise from quantum entanglement, which Albert Einstein famously peacock term called spooky action at a distance, including the notable special case of the delayed choice quantum eraser. This is not generally vague agreed upon within the physics community, because verifying non-local correlations requires ordinary subluminal communication, since the no-communication theorem prevents the superluminal transfer of information, and because fundamental descriptions of matter and forces require the full framework of quantum field theory, in which space-like separated operators commute. Accounts of quantum entanglement that do not involve retrocausality, generally vague, emphasize how the experiments demonstrating these correlations can equally well be described from different reference frames that disagree on which measurement as a cause versus an effect as necessary to be consistent with special relativity. The description of such non-local quantum entanglements can be described in a way that is manifestly free of retrocausality, if the states of the observers are included in the quantum treatment, which is often, but not exclusively, associated with the many-worlds interpretation. Retrocausality is also associated with the two-state vector formalism in quantum mechanics. Two-state vector formalism, a description where the present is caused by quantum states of the past and the future taken in combination. One physicist has reportedly presented the design for an experiment to test for backward causation in quantum entanglement to begin in 2007. Hypothetical superluminal particles called tachyons would have a space-like trajectory, and thus move backward in time according to observers in some reference frames. Despite frequent depiction in science fiction as a method to send messages back in time, theories predicting tachyons do not permit them to interact with normal tardionic matter in a way that would violate standard causality. Specifically, the Feinberg reinterpretation principle renders impossible construction of a tachyon detector capable of receiving information. Within modern quantum field theory, tachyons, or particles with imaginary mass, are interpreted to signify that the theory has been expanded about a configuration that is a local maximum of potential energy, instead of a local minimum. As parascience. Outside the mainstream scientific community, retrocausality has also been proposed as a mechanism to explain purported anomalies, paranormal events, or personal events, but mainstream scientists generally regarded these explanations as pseudoscientific. Most notably, parapsychologist Helmut Schmidt presented quantum mechanical justifications for retrocausality, eventually claiming that experiments had demonstrated the ability to manipulate radioactive decay through retrocausal psychokinesis. these results and their underlying theory have been rejected by the mainstream scientific community, although they continue to have some support from fringe science sources. Efforts to associate retrocausality with prayer healing have been similarly discounted by a legitimate scientific method.